All right, everybody. It's a great Friday afternoon on the 3rd of October. Just checking out the sun today. Got a little bit of clouds in. Figured I'd get just a little bit of solar live stream in just to show you what's going on. Got some really cool features going on. Um, just sit back and relax and enjoy the view. Sorry I don't have any high-speed music be playing at the time, but maybe next time we'll get some of that going. But just to kind of show you what we got going on today, some really cool looking sunspots. Lots of activity going on around the sunspot, as you can see. Let's see if we can't highlight that just a little bit better. So you can see inside this sunspot. Oh, sorry, pardon me. There we go. You can see right inside the sunspot here the activity going on. That's really nice. Look at these filaments here. Some rope filaments. It's looking really nice. And let's take a look and see what's going around the rim of the sun today. Quite a bit of activity there. Check that out. It's pretty good. Prominence is going on. That'd be a pretty good time lapse right there. That's looking really, really cool there. It's a couple 100,000 kilometers up in the space away from the solar surface. That one's pretty neat. That looks pretty cool right there. All right. So let's get this back to a normal view here. Take the exposure back down. And we'll give you what it looks like without the solar colorization, just black and white, since we're using a black and white camera here. Let's get it contrasted up a little bit so you can see it a little better. There we go. Now you can see the features again, just without it being polarized by the sun. So we have some rope filaments here going along through here. Again, the sunspots going on. This is a lot of activity going on. This is where some flares would or could be going on if we watched it long enough. Some really good hot spots going around. And again, this is what the rim of the sun looks like today without the color added. So we're just sitting here watching the sun today for a little while. Hope everyone's having a good Friday. But we are using the Lunt Solar Systems LS60 MT modular telescope. It's a hydrogen alpha filter, and we're using the Player One Apollo M Max 428 camera, and we're using the Skywatcher Solar Quest mount just as a quick setup. So if I were go to adjust the focus and just tap it, it bounces around quite a bit. So, and we're on the porch, so we're having to deal with moving around too much, causing the screen to shake. So, my apologies if the screen shakes. But this is what we got going on today, and I hope everyone's having a good Friday. Um, it's a beautiful day out. A couple of bit of clouds, um, not too bad. And I think while we do this, I'm gonna set it up to take some images. So let me get this thing set up and focused in to where I can take an image, and then I'll get it back to where it's supposed to be. But let me get it focused up. The best that I can get it. That looks pretty good right there. Let me reset my histogram here. Try to get it between 75 and 85%. That looks good. We're going to do a start capture here. Let's do it to sun. We'll do unlimited, and I'll capture around 2,500 frames. And then don't need that many, but that's just in case something cool comes flying by. You never know what comes by: a satellite, space station, a plane, a bird, um, SpaceX rocket or something. But um, I'll take those 2,500 frames, and then I'll stack those down. I'll stack them and only keep the best, maybe 25% or so, and then produce a picture of the final image. But we've got about 1,500 frames captured so far. We got about a 42 frames per second frame rate. It's not too bad. Coming up on 2,000 frames now. And we'll stop it right around 2,500 frames. I know you probably can't see that counter ticking away down there, but there we go. We just captured that. So we've got our picture, and I could stack it and show you in real live time what it looks like, but we'll just stick with looking at the sun for right now. All right, let's get it back to where it looks decent. We can keep an eye on this activity. Let me get it zoomed in a little bit more on those hot spots. That's what we want to watch for now. Might get lucky enough to see a flare. But as you can see, the sunspots really looking good. I'm sorry, I'm leaning in because the glare of the sun is pretty bright. But again, thanks for joining in. If you're just joining in, we are looking at a live view of the sun today. We're using the Lunt Solar Systems LS60 modular telescope. It's got a hydrogen alpha filter on it, and it's right up here. This is the scope up here. This is the Player One Apollo MX 428 camera. Got the cooler on top, and I got a little. I made a little sunshade to go on it to try to keep the cooler temperature down. The temperature is running about 33 degrees Celsius, so it's not too bad. But it takes on average, 8 minutes and some change, 8 minutes, 20 something seconds. It depends on the distance of the sun to the earth for the light to reach. So um, if there were a solar flare, going on in this region right here, we would see a nice little cool flash and maybe some activity coming in. But it would be, if it happened now, it would be 8 minutes and, down the road before it came on. So, but like I say, we're just chilling out, watching the sun today. Yesterday or the day before, I can't remember, it was very, very active. And around the rim was very active. Um, and if we were videoing this right now, um, if you haven't seen any of my lives, my not live streams, but if you haven't seen any of my time lapses, you should go check them out because all of these little filaments and prominences, they all move during a time lapse, and that's what you get to see. Like this little rope filament right here. It's not little by any means, but it sure looks little. But it'll move back and forth in the time lapse, and then around the rim of hang on 1 second, around the rim of the sun, the prominences really seem to dance. Um, there's been some coronal rain where the plasma shoots out and then rains back down, back to the solar surface. And as you can see right here, there's a lot going on today. Um, this particular one up top would be a really cool time lapse. And this particular prominence down here at the bottom, it would probably be moving and shaking as well. But that's really cool to see if we can't get zoomed in just a little bit more on those prominences up there. And let's see if I can get it to focus a little bit better just on the prominence. Not going to guarantee anything there. And if we take the, there we go, we bring it down just so slightly. Now you can really see that prominence up close. Whoops, sorry. And there it is right there. That's just plasma sitting there being pushed away by the magnetic forces off the solar surface, just sitting there hanging out, and then it's moving around and it'll float around and then go back down over time. But again, apologize for the bumpiness, but we're on my porch, and any slight movement causes this little mount to shake. So I apologize for that. But these are really cool. I could probably try to here in just a minute. Let me go back out to the full view of the sun. And we can probably try and put in a Barlow. That may take a little bit of finagling, but I think I could probably get that done. Now I got to go back and refocus back to the surface. So give me 1 second here. Get this refocused back up on the surface. There we go. Wow, that's looking really good right there. Let's turn the gain down a little bit. There we go. Let's brighten it up just a little bit. Yeah. Those are really, really nice looking sunspots right there. All right, let me take a quick second look at something here. Let's see, old geezer gazing. Hey, how's it going? Sorry, I'm just now checking out the chat. Glad to see you there. Microphone is very low. Okay. Let me see here. I got it turned down a little bit because of the wind. I'm going to bump it up a little bit. So hopefully that's better for you there. Give me a thumbs up, or if you're still in the chat, let me know if you can hear me better. And then I'm going to boost up the gain a little bit on this side here. So hopefully that's not too much and too overpowering, but hopefully that works. Okay, awesome. Well, I hope everyone is having a great day today. And again, we're just checking out the sun in real time, live view from the Lunt Solar System's LS60. This is a really cool modular telescope, meaning that it's 3 telescopes in one. You can actually take the camera out, put an eyepiece in, and visually look at the sun with the filters inside and the blocking plate installed. So you have to do it properly. So first of all, let me say, never look at the sun without the proper equipment, which we are doing, and we have the proper equipment. And then you can image with it the sun like it is now. And then, so that's 2, you visually or image the sun, or you can take off this hydrogen alpha filter here and put the telescope back together, and it becomes a 400 millimeter refractor. And you can visually look that way, or you can image the night sky with it. So it's a pretty cool little scope to do that. I haven't tested it out yet to do that amongst all the other stuff that I've been doing. But that's what we're doing today. And then we'll give it just a few minutes here. And what we'll do is we'll put in a zoom, maybe put in a Barlow, maybe a 5 times Barlow, and we'll try to zoom in on this sunspot to see how well we can get up to it. If you want to see that. So let's darken it down just a little bit for the contrast, so you can see that just a little bit better. And I don't really like the way that this thing jumps around. Hang on, let me zoom in a little bit. There we go. Sorry about the bouncing around, everyone. But hopefully we'll catch a plane that flies by. There's one over there. Sometimes we get lucky and we'll see one. We'll see one come by, but who knows? All right, so sit here, take a look at the sun. Let me zoom back out, and I'm going to try to get a Barlow set up. So just bear with me here. It's going to shake a little bit. The camera view is going to go away, but I'm going to put a Barlow, a 5x Barlow in, and let's see if we can't get the a zoom going on. Zoom up really close and tight to that sunspot. So give me just a minute here while I get this set up. And what you're going to see is we're going to use a Telview 5x Barlow with a Player One solar tilter. And what that tilter does is when you use a Barlow, I'm not sure why it does, but there's these Newtonian rings that form in there. There's little round circles. And if you use a tilter just a little bit off axis there, it'll supposedly get rid of those rings. Sometimes I can make it work, sometimes I can't. So give me just a minute here. Things are going to bounce around for just a minute. And here's I do a lot of 3D printing. So here's a little 3D printed sunshade that I made for the camera. All right, so here we go. Bear with me. And we're going to switch it over to this Barlow lens. So just give me 1 minute. See if we can't make this work. All right, so just bear with me here. I got to make some adjustments to what we got going. Whoop, there's those Newton rings. It's going to slow the camera speed down here. So I just got to take my time and adjust it. And I'm not going to try to adjust those rings, but I am going to try to get it focused back up. Bear with me here. Whoop, there we go. Just passed it. When you have a Barlow lens, the focus is really, it's so finicky. All right, so now that we have that, let me get some more things adjusted here. Hang on just a second. Okay, now I gotta adjust where the scope is pointing to get back onto the sunspot. So give me just a minute, and you can kind of see those little Newtonian rings there. And everything is backwards now that I've changed it, so just bear with me. Gotta find those sunspots. Oh, we're getting close. Nope. All right, there we go. All right, let me try to get it adjusted a little bit more, just a wee bit more. I promise you, I'll get this thing down pat one of these days. I got to keep this thing from drifting too. All right, almost. There we go. All right, so let's get the focus a little bit better, if we can. All right, I'm not going to touch it anymore. Let's bring the contrast up a little bit. There we go. How about that? That's really up and close and personal on that sunspot right there. you can really see. Looks like we're down inside those filaments here. The activity, that's a lot of activity going on. Let's boost it down just a little bit so we can get the insides of those little inside of the sunspots come up. You can kind of see those little rings in there. That's those Newton rings I was telling you about. But this mount is so finicky. I don't want to adjust it to try to tilt it anymore because it's gonna bounce around. And I don't want it to lose its place of where it's at. But that's a really beautiful looking sunspot. Really zoomed in. That's using a 5 times Barlow on that. All right, let me see here. Let's see if we can get it around to, and that's zoomed all the way out. Now what we can do is try to come in a little bit more, 50% more. There we go. That's a little bit closer. Feels like we're inside the sun. That's a pretty amazing thing. So if we were going to have a solar flare, all this hot spot of activity here, it would jump out. It would want to come out from around this sunspot. And then if it's strong enough, it can break free with enough force, we'd have a coronal mass ejection. And this particular one here, this particular one that we're looking at is facing us. So if it were to be strong enough, if we had a flare or a coronal mass ejection that was strong enough, it could give us a solar storm for some northern light action. But let's go up to see if we can see the prominence, and then we'll take the Barlow out. So there should be a prominence right at the top here. There we go. And let's boost it up just a little bit. So we can see that. There it is. It's coming into play now. I'm going to have to turn the gain. I'm going to have to turn the gain up because the exposure time is wanting to freeze the camera up. So give me bear with me a moment here. We'll turn the gain up. Oh man, look at that. Now that's pretty cool. We're really close on that that prominence right there. Now if we left it right there, if we left it on that prominence for 30, 40 minutes, and like I said earlier, it takes about 8 minutes, 28 seconds. So let's just call it 8 minutes for that light from the sun to reach Earth. We could sit here and watch that prominence grow or retract, over time, 30, 40 minutes down the road. Usually my solar time lapses are anywhere from an hour to 3 hours, and there's lots of stuff going on. And I just put out a solar time lapse this morning from a couple days ago, and that's some really cool solar activity going on that. But this is huge. This is, the cursor that I have right now. Let's pretend the cursor is the Earth. So the Earth is smaller than that cursor right now. That's probably 150 to 200,000 kilometers high off the solar surface. That's how high this prominence is going. But that those things are really cool. I can't really get any zoomed in closer. If I had the other mount connected, we could probably put a 3 times or another 2 times Barlow on that, and we could try to get a little closer. But we've kind of really maxed out the capabilities of this solar scope. But still, that's pretty amazing. Well, I think it's 93 million miles away. Don't quote me on that. I should know that by heart, but that's about it's about as maxed as we can get using this particular setup to capture that. But that's still amazing to be able to watch. Now we can get in a little further, but it's just a zoom quality, so the quality of it is not that great, if you know what I mean. But that's, that digitally it doesn't look pleasing to even sit there and look at it. But those are pretty cool, nonetheless. Let's see about going down to the bottom, and we'll take a look at that bottom prominence, and then we'll go back to look at the we'll go back and look at the sunspots. That's where a lot of the activity is. This is really cool to watch, but it's really cool to watch in a time lapse. That's the best time to watch it, is when there's a time lapse going on. And sorry, we're just trying to get back. Oh, there we go. Let's get this one going here. Let me get it moving in the right direction here. Sorry, y'all. Whoop. Everything's backwards on this particular scope control here. All right, there we go. I got to stop it from drifting. And let me turn the exposure down, and I'll bump up the gain. Wow, look at that. Now that's cool right there. That's almost like what we call a hedgerow prominence. And it's about the same. It's about the same distance, 150,000, 200,000 kilometers above the solar surface. That's pretty cool right there. And I'm sorry that it is pretty windy. I don't know if you can see the trees blowing, but it is pretty windy. And I'm on my wooden porch, so it's bouncing around quite a bit. There is a little bit of atmospheric disturbance going on, so you're going to see some of that waviness, and we are zoomed in incredibly close. So that's another reason it's jumping around. But that's amazing quality right there, in my opinion, on a solar prominence using a 5 times Barlow. That's really getting in there. Now, what would be really cool is if we can get a plane to fly by at the moment. I'm trying not to look at the sun here, but it's getting kind of hot. Got some clouds coming, but if we can get a plane to fly by, that would be pretty cool. I've only seen a couple of those, and I've done I did capture the International Space Station once. All right, so we'll give this just another minute. Checking out the huge hedgerow prominence here. And then we're going to go back, look at the sunspot, and then we'll go back to the full view of the sun without the Barlow. Just in case we get a plane to fly by, we want to see that whole thing go by. That is pretty cool. Thank you so much there, old geezer gazing. I'm glad you liked the view. Thank you for participating in the chat. Thank you for being here. Thank you for everyone for tuning in, even if you just tuned in and dropped out. Thank you so much. I call this Furlough Friday. Since the federal government has shut down, I'm able to do a solar live stream. So thank you for tuning in. Thank you for participating in the chat. I have not yet, old geezer gazing, I have not had the chance to be up close to a sea star yet, but I'm hoping that somebody will send the channel one for review. So I can't wait to see what that thing can do. I've heard a lot of good things about the sea star. All right, so let me get set back up on the sunspot. So just give me just a minute. We're going to it's going to take me just a minute to get back to where I was on the sunspot. There's a really nice filament. That's a really cool looking filament right there. Got a little bit of solar activity, a little hot spot going on right there. Ooh, there we go. That's a beautiful looking filament. It almost comes back and connects. All right, so let me see if I can't. There we go. All right, just gotta keep it from moving. There we go. All right, there we go. Wow, now that's cool. Um, that's looking really good. I think this filament is more defined now. And then keep in mind when we're looking at this filament, this right here, this cool looking structure right here, that's not really on the surface. It's straight up it's going straight up. We're just looking down on it right now. And all of those things that we saw around the rim of the sun, those prominences shooting out, if we were to rotate the view and look at it from the side, those things would be shooting out as well. And they would be going out and coming back down. And that looks like a loop prominence there. Let's darken this up just a little bit with some contrast. And let's take out some of there we go, some of the exposure. And we're going to bump the gain up just a little bit. It really accentuates those hot spots going on around the um, the area of the sunspot, which you can really see this part of the sun right up here. It's really hot, but there's no activity as much it is around the sunspots. And usually the activity is around the sunspots. They don't always have to be, but this sunspot is basically just a cooler spot on the sun, which is plasma being levitated off the surface of the sun by its magnetic field, and it's just floating around, and it's a little bit cooler. Not a lot, but a little bit. That's why it's a little bit darker. But when these things form, let's see here. See if I can't focus a little bit better. Whoops, sorry about that, y'all. Sorry. All right. So when these sunspots form, it looks like a sunflower, and the little sorry about that. The little area. Wow, I don't know if I can zoom in any better. Let's see if I can. Hopefully I can. Want to show you what I was talking about. That's about as good as I can get it for a second. The area around the sunspot, because we're really zoomed in there, they actually have those filaments coming off from the side of it. And when they get to a certain point, the sunspot um, could be breached, kind of like if you draw a line in it, and it's like a light bridge. It's kind of like a bridge of rope filament coming through there and cutting the sunspot in half. It's called a light bridge. I've only captured that once, and it looks like right here there is one right here. It's just too hard to tell if that's an actual light bridge. That looks like that's not a light bridge. That's a filament going over the top of that sunspot there. But that is nonetheless really, really, really cool. All right, we'll just check these sunspots out for just another minute, and then we're going to take out the Barlow. Oh, what is that? Oh, there's a huge cloud. You see that where it got really dark for a second? Um, Not a huge cloud. It's just a tiny little cloud. It's getting ready to go by. And there's a plane. Oh, we're so close to seeing a plane transit the sun there. That's close. But that cloud, there it goes. You can see the clouds going by right now. That's pretty cool looking. So that's the clouds trickling by. And it's only going to be for another second or two, and then it'll be gone. And as you can see, it's getting brighter and brighter and brighter. And there you go. Clouds are gone. And I think I'm going to take this time, now that we're back on right here, I'm going to go ahead and take this time to go ahead and set back up full screen on the sun. So give me just a second, and we'll tone this down so I can show you one more last time on the really active areas around this sunspot today, as you can see right here. All right, there's those are. Let me swap it out. It's going to go blank here just for a second. So let's adjust this. Let's adjust this. Um, it's funny. It's funny, but not funny. The other day I was trying to get um, ice cream out of the bucket, and I actually injured my finger trying to get ice cream out of the little quart, the gallon. That's a half a gallon of ice cream. Um, and man, it feels like I jammed up my finger really bad. So I can't. It's hard to grip and twist. All right, let's get this thing adjusted where we need to be. So stand by just for a second here. Let's get the sun loaded in. One of these days I'll remember which way is forward and backward. All right, so I think I got that there. Let's put the solar tilter up there. All right, let me get the gain adjusted first and bring down the exposure. And then we're just going to require some focusing. All right, so stand by. Let's get some focus going on in here. There we go. Let's take the solar colorization off. So we're looking at black and white here. I'm going to boost it up just a minute so I can get the focus. It's a little easier to focus in black and white and when I put a lot of contrast in it. So let's get it zoomed in really far as we can get it. And it's easier to get focus when you have something to contrast against. I don't have anything really bad to say about Lunt. Lunt is a great solar telescope, but what I will say is their choice of focusers, I don't like it. It's too much play for me. I would rather have uh, a more robust, better built focuser than that. All right, so there we are back. Um, back on the sun full screen. Let me put up this Barlow lens here. Try to keep it clean. All right. There's the sun. Let's give you another view of the, oh, here's another cool view. Check this out. This is an inverted view of the sun. And what it does is, rather than accentuating certain areas of the sun, when you invert it, the filaments that run along the solar surface really stand out. As you can see here, they kind of like pop out 3D, in my opinion. And when you get a little closer to them, they just look more alive. And then you can adjust it by adding contrast or taking away contrast. It just gives you a different view of how the sun looks. Anyway, I just wanted to show you that because looking at the sunspots look different. You can see it's really pronounced. You can really follow that rope filament going on right there, and then you can really see all of the activity going on in that sunspot. I mean, it's really bright. It stands out. Now, if we were watching this and we watched it for like a time lapse, and it's really dark in this area right here, and what we look for to see the solar activity or a hotspot is 30, 40 minutes from now, if it's going to act up and create activity, that area would become bright like this sunspot. It would just start, it would change colors. Let's bring this back and let's let you see the rim of the sun in that same instance. But now you'll see the prominences around the solar surface, the rim, a little bit better. How cool is that? Now you can really see how those look. Those what we saw before had some false color added, and now we're looking at it inverted. And now that what that's done is that really brings to light this super huge rope filament here. Not rope. I mean, that's not a filament. Prominence. Excuse me. This loop prominence. Prominences are what are prominence and filaments are the same. Just depends on what view you're looking from. All right. Sorry about the chat, y'all. I'm catching up with the chat. Mohammed. Do sunspots mean solar flares? And is that biggest sunspot? Is that biggest sunspot on the sun right now? Yeah. So that sunspot is on the sun right now. And let's see here. Hang on. Let's go back to where we were. I'm sorry, y'all. I'm not keeping up with the chat. Let me get this back to where it needs to be. There we go. And let's zoom into this sunspot right here. Let's add a little splash of sun colorization. And then let's just brighten it up ever so much. Sorry. There we go. All right. So yes, the sunspot is on the sun right now. And do sunspots mean solar flares? Well, yes and no. If we're going to have a solar flare, there's a better chance of that solar flare coming out from around the activity of that sunspot. And I think the reason that is, and that this is me. I'm just a self-taught amateur astronomer and solar photographer. What I believe is that since that sunspot is basically floating up and being lifted up off the solar surface by the electromagnetic fields going on, that's giving there's some. It's kind of like if you had a crack in the ground, if you had a pressure under the ground and you took a piece of that ground up, it relieves some of that pressure. So some of the gases or the water could come out. Well, I think, in my opinion, whether it's wrong or right, it feels like that there's a little bit of pressure difference there that it makes it easier for the plasma to shoot out for a solar flare around that area since it's already off the solar surface, if that makes any sense. Ross Hampton, welcome in. Glad you're here. Thank you. Appreciate that. So Mohammed says, so bigger sunspot, bigger solar flare. Yes, I do believe so. If you have, well, it's kind of like an earthquake or a volcano. You could have a big volcano and have a little small explosion, but you could have a situation to where that a bird just flew by. I'm sorry about that. So like squirrel, you could have a situation to where you have a huge solar flare around a smaller sunspot. But I feel as if, yeah, you're going to have a way bigger, like what we're seeing right now. All of this activity around this solar sunspot, that solar activity, all that stuff going on right now, I feel as if we were going to have a gigantic solar flare or even a coronal mass ejection, it would be right there. It would not be over here or over here. There is some activity going on up here, but it's minimal compared to the activity going on right here. So this is probably where it's going to be focused and go right there. New phone, who dis? Thanks for joining in. Are you going to be looking at 3i Atlas tonight near Mars? Oh, everybody, pay attention. Here it comes. Here it comes. We're going to zoom out. Check this out. Check this out. Fingers crossed. Here we go. Here comes a plane. Is it going to make it? Is it going to make it? Oh, we're going to be inches. Come on, come on, come on, come on. It's so close. Oh, I think it might be down over here. I think we're going to miss it. I think we're going to miss it. Oh, we just missed it. It is literally, it's right there. Sorry, y'all. Oh my gosh, that would have been so great. I don't know. I think where I'm at located right now, I haven't been tracking that one. I think I saw somebody take pictures of it the other day, and it's so, well, as you can see right here, I've got trees all around. I'm on the porch. And the last time I caught the comet, I had to travel to go see the comet. Um, I think it's so low to the horizon right now, I won't be able to see it tonight. However, if it does travel back around and it comes over my part of the sky, oh yes, I'd love to live stream it and do that. So just if you haven't subscribed already, subscribed and turn the alerts on, and then if it's out there, I'll track it down and we'll try to take a look at it. All right, let's see here. It is really starting to warm up right now under the sun. I hope everyone is doing good. And for those of you who just joined in, I'm using the Lunt Solar Systems LS60MT. It's a modular telescope. It has a hydrogen alpha filter here. It's pressure tuned, and using a Player One MMAX 428 camera. Also with the Skywatcher Solar Quest mount. And what's really cool about thank you, new phone who dis. I really appreciate that. NG's old geezer says he's currently, or that person is currently looking at NGC 688, the Crescent Nebula. That's awesome. That's awesome. That would be. I haven't been able to image the Crescent Nebula in a while. But what's really cool about this telescope is the pressure tuning ability. So it's going to bounce around, y'all. So just bear with me. But what I'm going to do is I'm going to off tune the the pressure here, and you'll be able to watch all of these gradients, the features go away. Wait a minute. Wait a minute. I hear another plane. I don't want to mess up possibly catching another plane here. Oh, I can't see the contrails on that one, so I don't know if he's close or not, but wow, it would be cool. All right, so here we go. I'm gonna back off the pressure. And then now you only see a sunspot. So let's bring it down. So now if you can see now the sun, you don't see all of those filaments. You don't see all of the prominences hanging around. We're basically just looking at, oh wow, did y'all see that? I think that was a bird that just flew by. That was pretty cool. There goes another bird. Well, right now we're just looking at, it would almost be like a white light telescope where we've gone off band, so to speak. So they call it when you're looking at the hydrogen alpha, and it's all right in the sweet spot. I forget what the pressure is. There's a certain tunable pressure, but it's called on band. And right now we're off band, and we're just looking at the sunspot. So that's one cool feature of this telescope with the pressure tuner is you can pressure tune it to just look at certain features. Now we can do this. We can bring it up like this, and we can adjust the gain just a little bit, and exposure, And so now you see these individual prominences up here. You see them a little bit better than what we had before. But what I can do is when we adjust the pressure tuner even further, sorry, it's bouncing around, they'll go away or they'll get made crisper. And it's all depending upon the pressure that you have tuned in. So let's get that tuned back. But wow, that prominence down there, that prominence is looking really good. Look at this. That's looking pretty sharp right there. I mean, that's pretty clear. That's clearer than what we had before. That's looking really, really good. Kind of wish we would have had that done before. So new phone, who dis? Thank you. I really appreciate that. Old geezer gazing. You're in the UAE. Oh, that's awesome. Thank you for tuning in. And thank you for everyone tuning in. That's awesome. Whoever's in the chat, throw out where you're where you're coming from. This is from a backyard in South Carolina, in central South Carolina. And right now, there goes another plane. Right now, that is the best looking prominence right now that I've seen so far. That's really cool right there. What we've done is we've tuned it off band to capture that prominence, that solar prominence right there. Let's see, Yosef Mohammed. How long until it makes a solar flare? I want to see an aurora in my area. Well, that's kind of hard to tell because the sun is tricky. It could go all day and just be nothing going on. And then 8 minutes later, bam, we've got all this activity. We've got all these solar flares going on. I'm with you. Last May and last August, we had some really good solar activity, a G4, G5 magnetic storm. And even here in South Carolina, I was able to see the aurora borealis. Got some really cool pictures of it. Wow, the sun's really picking up right now. But anyway, this is the best this has ever been right here. Clarity right now. And again, this is about 150 to 200,000 kilometers off of the solar surface. That is really cool. Please don't forget, if you're here, smash that like button. It means a lot. Connecticut. All right, so you're over in Connecticut. That's awesome. We got someone from Connecticut. We got someone from the UAE, which is pretty cool. I'm here in central South Carolina. I really appreciate you all being here. If you want to learn how to process solar images, if you're not subscribed, please subscribe to the channel, but you don't have to. But go on in there. There is a video that I posted. It's called How to Process Solar Images. And inside that description, there's a link to my Google Drive where I put my solar data on there. And you can follow along and process that data and create you a picture or even a time lapse. Now, I tried to upload that full 3 hours of data, and we have Starlink internet here. It's great, by the way, but it's difficult to upload 3 terabytes of data, so it kind of broke my my Google Drive, and I don't have that much data space anyway. It costs a lot, so I had to, unfortunately, only put a little bit of data on there. But anyway, you can go to that video, click on the link. It's safe. It's my Google Drive, and you can actually process and practice doing those. All right, so let's get back to the full view of the sun here. That's looking really cool. All right, so let me retune and get on band with the telescope here. So let me adjust back to where we were. I got to get it in about the right area so I can notice. And if you notice right now, we're back to just being a plain sun here. When I say plain, there's really not a whole lot of features going on. But what I'm going to do is I'm going to slowly adjust it, increase the pressure. Sorry for the bouncing. And you'll notice the features start to take shape again. And it got darker. And also on this mount, unfortunately, it will move the mount. So let me get the sun situated back again. All right, so now I got to readjust the gain, get us back to where we were, and get us focused up again. So just bear with me, please. Let me get this thing focused up. I'm going to take off the solar colorization, go back to being regular, and let me focus in on here the best I can. That's pretty good. All right, so let's take a look at those hot spots. Put the color back on. Let's get zoomed back into these really cool sunspots here. All right. All right, so Muhammad says, so it's random. We might never know when it, that's correct. That is correct. It is random. However, um, as long as I've been viewing the sun, and I could be totally wrong, but as long as I've been viewing the sun, I'm gonna show you something here. So in this area of the sun here, I'm gonna see if I can't. Hopefully you'll be able to see this. I'm gonna put a circle. So well, it's too big of a circle. All right, so right where this crosshair is, there's activity, but there's not a lot of activity here. We'll zoom in. There's not a lot of activity here. As you can see, it's really bright over here. Well, right where these crosshairs are, there's not a lot of activity. So as long as I've been watching the sun and viewing the sun, I would say that there's a very small chance that there's going to be any activity jumping out from right there. So if the entire solar surface looked like that, no sunspots, just a filament or two, I would say a couple hours, there's probably nothing going on. But with the sun looking like this, and with all of the solar activity going around that sunspot, with the solar activity going around there, I would say that, oops, sorry, I hit the wrong button. I would say that any given time, whether it be an hour, whether it be 30 minutes, we could actually see a solar flare around this area. It just depends on the activity that's going on. But there is a lot of activity going on right there, as you can see. Let's further dim it down a little bit. So just with it being like this, and I darkened it up and contrasted it up a lot to show you this is where your solar flares are going to be. This is where the hot spots are. And if a solar flare was going to jump out, this is where it would be right now on the surface of the sun, because there's not that much hot spots. Well, actually, I'll take that back. Look right here. Let's look at this. There looks like there is starting to be a solar flare activity right here. Now let's see that little tiny one right there. It's starting to act up. There is a sunspot in its location, so there could be some activity. It's growing, because earlier that really wasn't going on. And I've been streaming for an hour now, and I would say an hour ago that wasn't there. So that's an indication that this area right here is an area to watch. But this area that's right there, if you look at it, it's kind of off axis. It's not really looking straight at us. It's kind of off to the side a little bit. So if this particular one right here had a solar flare at the right now, or a coronal mass ejection, we get a little bit of it. But if this one right here in the center at a big solar flare or a coronal mass ejection, we get the full frontal of it because it's facing us, if that makes sense. All right, Ross, that sunspot is about 11,500 miles wide in the darker spot only. Yeah. If you include the outside cooler portion, the sunspot is about 19,000 miles wide. It's insane, right? It's incredibly, incredibly huge. Just looking at that, that's awesome. That is so cool. So for those of you who just joined, we are watching the sun in real time from my back porch in central South Carolina. We are using a Lunt Solar Systems LS60 MT modular telescope, meaning this telescope can be taken apart and used 3 different ways. We could use it, we can image with it right now as we're doing. You could take out the camera, put in an eyepiece, and let me say, before you put an eyepiece into any telescope and look at the sun, please use only proper equipment. We are using proper equipment here. This is a certified dedicated hydrogen, it's not dedicated, but it is a certified hydrogen alpha telescope that is designed to use safely for the sun. Take this out, put an eyepiece in, and modular meaning we could take this solar filter out, put it all back together, and visually use it to look at the moon, or put a astronomy camera in it, or DSLR camera, and we could image with it as well. So that's what we're using. The mount we're using today is the Skywatcher Solar Quest mount. And I must say that if anyone is interested in any of this equipment, please see my good friend Dan over at astroworldtelescopes.com. You can get your entire solar setup from astroworldtelescopes.com. All right. We're going to look at, I'll give you one last look here. We're going to wrap this up. I need something to drink, and the sun is baking me. I don't have any sunscreen on. It's getting pretty hot out here. We're getting close to the trees in the house on this side. But we'll let you take a look at this sunspot another few minutes while we wait. It's been an hour since I took the last photo, so let me do that. Let me set up inside of Sharp Capture. We're using Sharp Capture here. Let me take a photo. So what we're going to do here is bring this back to here. Let me get this set up and get set up on the same. Let me focus and get this thing set up to take a picture, and I'll be able to tell what the difference was an hour ago versus now from a picture. All right, that's about the best zoom. I mean, the best focus I can get. So let's bring this down to about 75% on the histogram. Oh, it's being touchy today. All right, so let me get a quick capture here. Well, trying to. There we go. We're going to do unlimited. We're going to capture about 2,500 frames. So here we go. We're capturing frames at about 42 frames per second. Yeah, enjoy your beer. That's right, old geezer gazing. We are capturing about, we're going to get about 2,500 frames. Again, I like to do that to get about 2,500 frames in this .scr file, and then I'll run it through AutoStacker and weed out about 75% of this. We want to keep 25% of that, and then stack it, and then process it in PixInsight for a picture. And what I'll do is I'll post the before, which is before the live stream, or at the beginning of the live stream and after the live stream, or at the end. So an hour apart. See what the difference is and see if we can see any of the filaments have moved, or any of the solar prominences have grown. Oh, we've gone over, so let's stop that there. All right, so we've captured that. We'll get you one last look around the rim here. Let's get this thing brought up. Let's get a look at wow, that looks pretty good there. Let's go inverted again here. And let's get it adjusted to where we can see the prominence is really good. We'll get zoomed in, let you look at those. One last look. Let's see if I can't focus in a little better. Yeah, it's about as good as I can get. That's still pretty cool looking though. I don't know if the solar colorization works when it's inverted. It gives it a purple tint. All right, there's that. Scroll down here. Let's look at this one down here. Yeah, I think the best view of these solar prominences is when we were off band, tuning it back off band, and then bumping the exposure down and bumping the gain up just a little bit, and that gave us the best look at those prominences there. So that is the sun today. I really appreciate each and every one of you for being out here today. Let me get this back down so you can see the sun before we exit. That's the sun today, and I'm sure that it's going to be producing some really cool stuff later on this evening, afternoon. But if I can get a chance to get those pictures taken, I will, and I'll get those published a little later on in a little small quick post. But there we go. Here's your last look at those really sweet looking sunspots. Let me get the gain boosted up. Whoa, just a little bit. See if I can't get us focused in on it a little bit better. There we go. That's a pretty good. All right, so I'm going to leave y'all with that right there. And again, thank you so much for hanging out with me today. To each and every one of you, I really appreciate it. Old Geezer, Ross, Mohammed, New Phone Who This, and to whoever else joined in. Really appreciate you. I love each and every one of you. Have a great rest of your day Friday. Maybe the weather will hold out for us. But again, thank you so much for hanging out with Wilfredo's Astrophotography and checking out the sun today. But enjoy your weekend, everyone, and hopefully we get to do this again. And until then, clear skies, but always remember to pick up your solar gear today or tomorrow at astroworldtelescopes.com. And see Dan and tell him Wilfredo sent you. I think he'll get a chuckle out of that. But y'all take care.